Hi everyone. Today's topic is about GPRS, which means General Packet Radio Services Architecture. GPRS architecture works on the same procedure like GSM network, global system communication, but has additional entities that allow packet data transmission. This data network overlaps a second generation GSM network, providing packet data transport at the rates from 9.6 to 171 kb per second. Along with the packet data transport, the GSM network accommodates multiple users to share the same R interface resources concurrently. In GPRS architecture, it introduces two new network elements. The first one is Gateway GPRS Support Node, which is GGSN, and the next one is Serving GPRS Support Node, SGSN. The diagrammatic representation, the architecture of the GPRS. The first mobile station, which means our mobile system is connected to base station subsystem, which is called telephone wired telephone system, and the base station is connected to serving GSN, and the serving GSN is connected to personal digital assistance PDN, and the base stations will send request to mobile station controller and to the location register, and SGSN is connected to mobile station controller and home location register or GR and to the EIR. This is the architecture for GPRS. In GPRS mobile station, new mobile stations MS are required uh, to use GPRS services because existing GSM phones do not handle the enhanced R interfaces or packet data. A variety of MS can exist, including a high speed version of current phones to support high speed data access. A new PDA, personal digital assistant devices with a embedded GSM phone and PC cards for laptop computers. These mobile stations are backward compatible for making voice calls using GSM. GPRS base station subsystem. Each base station controller requires the installation of one or more packet control units under software upgrade. The PCU provides a physical and logical data interface to the base station subsystem for packet data traffic. But the BTS can also require a software upgrade, but typically does not require hardware enhancements. With either voice or data traffic is originated at the subscribe model. It is transported over the air interface to the BTS and from the BTS to the BSC in the same way as a standard GSM call. However, at the output of the BSC, the traffic is separated. Voice is sent to the mobile switching center MSC as per standard GSM, and data is sent to a new devices called the SGSN via the PCU over a frame relay interface. GPRS support nodes. Following two components named Gateways GPRS support nodes GSNS and Servings GPRS support nodes SGSN are added. First one is Gateway GPRS Support Node (GGSN). The Gateway GPRS Support Node acts as an interface and a router to external networks. It contains routing information for GPRS mobiles, which is used to tunnel packets through the IP-based internal backbone to the correct serving GPRS support node. The GGSN also collects charging information connection connected to the use of the external data networks and can act as a packet filter for incoming traffic. And the next one is serving GPRS support node SGSN. The SGSN support node is responsible for authentication of GPRS mobiles, registration of mobiles in the network, mobility management, and collecting information and charging for the use of the air interface. It is an internal backbone of the GPRS node. The internal backbone is an IP based network used to carry packets between different GSNs. Tunneling is used between SGSNs and the GGSNs. So the internal backbone does not need any information about domains outside the GPRS network. Signaling from a SGSN to a MSC, home location register, and EIR is done using SS7. Routing area. GPRS introduces the concept of routing area, This concept is similar to location area in GSM, except that it generally contains fewer cells. Because routing areas are smaller than location areas, less radio resources are used while broadcasting a page messages. GPRS application, whereas the GPRS are used in communications. For communication, GPRS is used for transforming one communication to another through wired or wireless devices like telecommunication, for whatever it is. And e-commerce website, like e-commerce websites like for example Flipkart, Amazon, these are the e-commerce websites to communicate wherever in the world, to shop our products, like based on the category, based on the ingredient we have to shop. So that's why GPRS applications are used in e-commerce websites and value-added services. And the last one is location-based application. Mostly GPRS is used for location-based applications like GPS track, which is used to track wherever we have in the locations, or we are searching any new locations, or currently we are where we are in the locations that are used to grab using the GPRS applications. So that location based applications are used GPRS applications. And the next one is GPRS protocol stack. The flow of GPRS protocol stack and end-to-end message from mobile station to the gateway GSN is displayed in the below diagram. GTP is the protocol used between the SGSN and GGSN using the GN interface. This is a layer 3 tunneling protocol. From this mobile station, it is connected to base station, which is called mobile station, which means a mobile phone or a system, which is connected to base station, which means via the telephone, and it is connected to service GSN. And so through the service GSN, it is connected to gateway of GSN. First, the mobile station transfers the data to BSS, base station subsystem, which contains radio layers and lower layers. And the base station transmits the data to SGSN, service GSM. It converts lower layers and lower layers. And the SGSN transfers the data to global GSN, gateway GSM. So this is the protocol stack of GPRS. The process that takes place in the application looks like a normal IP subset network for the users both inside and outside the network. The vital thing that needs attention is the application communicates via standard IP that is carried through the GPRS network and out through the gateway GPRS. The packets that are mobile between the GGSN and SGSN use the GPRS tunneling protocol. This way, the IP addresses located on the external side of the GPRS network do not have deal with the internal backbone. UDP and IP are run by GTP. Subnetwork depend convergence protocol and logical link control combination used in between the SGSN and the MS. The SGNDCP flattens the data to reduce the load on the radio channel. A safe logical link by encrypting packets is provided by LLC and that same link. In case the mobile moves to a new routing area that lies under a different SGSN, then the old LLC link is removed and a new link is established with a new serving GSSN. So next topic is about generations of mobile communication technologies. First generation, second generation, third, fourth, and the fifth. So this is how the generation of mobile communication technologies are developed. So first generation, in first generation only voice over communications are introduced, and this in second generation through over the voice we have received a messages like text messages have introduced, and in 3G we have using voice message texting, internet access and video streaming are established, and in 4G also we have established voice message texting, internet access and video. Through over 5G it will be established all these communications in a boom networks, which means we have in 5G we have unlimited data, wherever we are using our mobile phones we have fetching unlimited data through wireless mode. From first generation, It uses analog technology that were introduced in the 1980s and continued until being replaced by 2G digital telecommunications. It introduced the following mobile technologies: mobile telephone system, advanced mobile telephone system, improved mobile telephone system, and push to talk. Features: maximum speed of 1G is 2.4 kb per second. It allows voice calls in one country. Use analog signal. Channel bandwidth is about 300 kilohertz. And the disadvantage is poor voice quality, poor battery life, large phone size, no security, limited capacity. To overcome this first generation's disadvantage, they have introduced the second generation. Second generation is based on GSM. It was launched in Finland in the year 1991. It uses digital signals for voice transmission. It will make use of either CDMA or TDMA, code division multiple access or time division multiple access. What are all the features in second generations? Lower power emissions. It provides a lower power for the battery consumptions. Data speed was up to 64 kb per second. Low data speeds are only gained through this generations. Use digital signals. From first generation, we have used analog signals to overcome the interaction to overcome the intermediates. We have used the digital signals for 2G. It enables services such as text messages, picture messages, and MMS multimedia messages, provides better quality and capacity. From first generation, we have only send the voice call. There is no message services also available. Limitations: requires powerful digital signals to work the mobile phones. It enables to handle complex data such as video. There should not be video options are not available. The third generation. It makes use of TDMA and CDMA. It provides value-added services like mobile television, GPS global positioning system, live streaming, and video conferencing. It is designed for multimedia communication. Features: fast data transfer rates, speed up to 2 megabytes per second. Send or receive large email messages. It provides seamless global roaming. Limitations: requires higher bandwidth, cost is high. And the next one is fourth generation. It is an all IP based integrated system, will be capable to provide 100 Mbps for high mobility and 1 Gbps. The user service include IP telephony, ultra broadband internet access, gaming services, and high definition television, HDTV, streamed multimedia. In this fourth generation mobile phones, there are lot and lots of features and applications and softwares are boomed in this generations. Features: capable of provide 10 Mbps to 1 Gbps speed, high quality streaming video, combination of Wi-Fi and WiMAX, high security, low cost per bit. Limitations: the battery uses is more, harder to implement, need complicated hardware, expensive equipment required to implement next generation network. And the last one is fifth generation. And 5G wireless technology is meant to deliver higher multi Gbps, peak data speeds, ultra low latency, more reliability, massive network capacity, increased availability, and a more uniform user experience to more users. Higher performance and improved efficiency empower new user experiences and connects new industries. Increased data transmission capacity 1 Gbps. Connectivity to a large number of devices due to the IoT. Period of estimation 2016 to 2020.